Sixth grade lesson 9.3 is problem solving, analyzing relationships. This one probably you don't really need me for. You're just kind of putting together, tying everything together that you've just learned and practicing it. You're given a table that has the information. You could utilize what you know about unit rates. There's a lot of avenues for solving these problems. You'll probably come up with one in your head that looks different from the way I do it or the book does it. Math is that way. There's lots of different tools you can use. And so, but we'll go ahead and go through 2 practice ones, and then you'll go ahead and do several practice ones aside from that. Just a really good lesson to practice what we've learned. And so let's go through the same way we always do. We start by reading the question, underline what they ask us to do, circle the information they give us, draw it if we need to for our brains to digest, and then proceed forward. They've also given us a template to use to kind of organize our thoughts on things. So this says the table shows the amount of water pumped through a fire hose over time. And here's the time, 1 minute, 150 gallons, 2 minutes, 300 gallons, 3 minutes, 450 gallons. If the pattern in the table continues, how long will it take a firefighter to spray 3,000 gallons of water on a fire using this hose? So there's our question. Let's underline it. The information they provided to us wasn't so much in the word problem as it was in the table. And we want to know how much time will it take for 3,000 gallons. And that's the first thing they tell us to do. What do I need to find out? We underlined it. We need to find out how much time for 3,000 gallons. Okay. And let's kind of break down what we know. We do know that 1 minute gives us 150 gallons. So let's go ahead and make that as a ratio. 1 minute gives us 150 gallons. So whatever amount of gallons we have, if we divide by 150, we should get that. Let's test that. 300 divided by 150 should be 2. 450 divided by 150 will be 3. 600 divided by 150 will be 4. So that relationship stays steady all the way through. I was testing to see, does it stay steady all the way through? And so what information do I need to use? I need to use the relationship between minutes and gallons. That's the ratio that we wrote off to the side over there. And we kind of got ahead of ourselves and wrote the ratio. How will I use that information? I will find a rate in the table and then write an equation for it. So we're going to use the table above to find the relationship between the time and the amount of water, or the rate that we got here. They say let T represent the time in minutes. So T is minutes. And W will represent the amount of water in gallons. The amount of water in gallons is 150, we discovered, multiplied by the time in minutes. So if it was 1 minute, multiply by 150, and that's what you get. If it's 2 minutes, multiply 2 times 150, and that's what you get. So we get our dependent variable, the amount of water in gallons, equals 150 times the time. So we can use this equation to find out how long it will take to spray 3,000 gallons. Remember, gallons is represented by W. So we're going to replace this W equals 150T was our equation. We're going to replace the W with 3,000. And so this just brings back into practice our one-step equations to isolate the variable. So my variable is here on this side of the equation, and I want to isolate it. He's being multiplied by 150, so I will do the inverse operation of multiply by 150. That is divide by 150. I have to do that to both sides of the equation, right? To keep the scale balanced. That cancels out, leaves me with 1T. And then 3,000 divided by 150 is going to be 20. So it will take 20 minutes to spray 3,000 gallons of water at that rate. So we use the information they gave us as a tool break it down to be usable for us. And then we were able to figure out, okay, it's going to take 20 minutes. Okay, let's look at one more example. And then I think you'll probably be fine to do this on your own. Dairy cows provide 90% of the world's milk supply. The table shows the amount of milk produced by a cow over time. If the pattern in the table continues, how much milk can a farmer get from a cow in 1 year or 365 days? I need to find how much milk in 1 year or 365 days. They give me all the information in days, so I'm just going to go ahead and put in 365 days. What information do I need to use? All the information in the table, really. These are ratios, remember? So 2 days gives me 50 gallons of milk. 7 days, 175. These are jumping by different numbers. But really, I'm going to focus on this one. If I have 2 days, that's a calendar, 2 days, and I get 50 gallons, then I can, in my mind, kind of break down the unit rate for 1 day, 25 gallons for 1 day, 25 gallons for the other day. That is the unit rate. So we can add that here. 1 day is 25 gallons. We could have done that mathematically rather than drawing. We could have said 50 liters in 2 days. What is that in 1 day? 2 divided by 2 equals 1. 50 divided by 2 equals 25. Do you remember doing that several lessons ago? That's how we would find the unit rate. So, but sometimes you can just see it. So in this case, in my brain, I could kind of just see what was going on. So I'm going to use the information, the unit rate, that in 1 day, there's 25 liters of milk by the dairies. So how will I use the information? Well, I know that I want to find out how many liters of milk, how much milk in 365 days. So if in 1 day it's 25 liters, it's 25 times 1. How many days and how much milk will that be? There's my equation. This is representing the amount of days, which they're going to tell me is 365. So it's 25 for 1 day, and then 2 day, and then 3 day, and 4 day. I want 365. This will tell me my total amount of milk. So now that I have my equation, and maybe you don't come up with the equation that way. Maybe you went another route. There's a lot of ways to do it. My brain goes to the equation because I've been doing this 6th grade, 7th grade, 8th grade math for a long time. So I'm used to seeing the equation that way. Now I'll just plug in for the days, 365. And I will calculate that. 5 times 5, 25. 6 times 5 is 30, plus the 2, 32. 5 times 3 is 15, 16, 17, 18. Cross off that placeholder. 2 times 5 is 10. 2 times 6 is 12. 13 with the carryover. 2 times 3 is 6, plus 1 is 7. Add that all together. 9,125 liters. So in 365 days, the farmer can get 9,125 liters. So the table, so you're going to get word problems where you're going to have to find some information. The table will give you information. It might not give you exactly the information you need. You might have to be a detective a little bit to break it down like I did here. But once I found out that 25 liters in 1 day, then I just had to multiply 365 days times the 25 so that I could find out how many total in those 365 days. You'll see a lot of that. You'll practice a lot of that. You'll get better the more you do it. Go get it.